Presenting. Excellent. All right. Thanks, guys, for asking me to talk about this topic. If I was to take the thing about Cloud Foundry, I picked up Cloud Foundry, picked up Heroku 2007, 2008. I was in love with Ruby on Rails, couldn't deploy it for shit, and Heroku was both cheap/free and made deploying Ruby on Rails applications really easy. Shortly after that, they came out with a thing called Buildpacks, which meant that Heroku could now deploy arbitrary things. So not just Ruby on Rails, but Java and Python and all sorts of different things. When Cloud Foundry first came out, it did not have Buildpacks, but when Pivotal took over the Cloud Foundry project, one of the first innovations they declared was a must-have was to bring in the plug-and-play aspect of Cloud Foundry, of Buildpacks. Now, I'm not going to spend a lot of time about what is a build pack, I think. But instead, fortunately, I get to give another talk tomorrow on how to build one. Many people, certainly you're going to just enjoy them. Other people will build the build packs, and that's part of why they're good, is that you don't need to know what's in them, except the value they bring. And at 11 o'clock tomorrow is office hours, so if you want to talk to the build packs team or members of them. Do I have any build pack core team here? Excellent. That's one. It's almost enough that I can't talk about them in a negative way, but not enough to feel like they're... No. If I say anything you want to clarify, correct, I appreciate if you chip in. All right, but I do want to get back to the problem. Now, this is for Kubernetes, but really, this is also for the future of Cloud Foundry, the V3 build packs that I'm going to talk about. When Kubernetes came along, it kind of glossed over all the problems that people had living with Docker and said, hey, well, let's just talk about scheduling. That's new. And we're still stuck with all the challenges of living with the packaging of Docker. And so therefore, in the thrill of getting our app running at all, I don't think we set ourselves up for success with the next 10 years, otherwise known as the day two problem. Bit like the sort of, in Genesis, day one, day two, day three doesn't necessarily mean days. Day two is 10 years or longer. And it's all these problems that exist in the life cycle of your app. Now, in an ideal world, you might get to separate them out by concerns to different organizations who might care about things. So you might be building a Java Spring app. That doesn't mean you want to care about what's the best way to run a Java Spring app or a Rails app, etc. But if you build a Docker file, then you've just given yourself that problem. And it might not be obvious to the organization that you've created yourself that problem or how to separate it out. Platform, different meaning perhaps when you use Kubernetes. Hopefully that becomes more clear over time. But this might be an ideal separation. Maybe more practically speaking, you might be able to split them out like this. And what I've changed in this case is to say that it's not really, if you've picked Ruby as your programming language, you really can't separate out dependencies of all the gems that you pick, or Node, the NPM packages. You can't sort of say, yeah, we'd like to use Express.js, but we'll let some other team figure out what version's the right version, and we'll just build features. It's a bit messier than that through the nature of packaging. So you're going to have some, and what version of Node do I need to use? What version of Java can I use? What version of Ruby? You can't just let some other team pick that, probably. So it's a little messier. But nonetheless, you do want to start thinking this through, otherwise the dev team disappears. Here's the problem, best put. I don't think I've got a chronological, but whilst the app lives for 10 years, the dev team lives for a year. And then they go off and build another app. Now who's looking after your thing? And so what actually happens is this sort of nonsense. Is the dev team turns up and says, this is going to be great. It's going to be a Ruby app. Look, I've got Ruby in there. I apologize if the font isn't big enough for you at the back. I cannot fix that now. The nature of a screenshot. I did try to make the smallest possible one that worked. So, I've overstated like you need those, but you really, for the sake of a demo, I could have skipped it. But anyway, but look at the top, from Ubuntu. Well done. Yeah. Imagine reading that and going, I have no idea what version of Ubuntu you used when you did this. Like literally, what was on your laptop at the time you did Docker build? And update get, that really what you end up with depends on the day that you did it. Apt-get install Ruby, who knows? It comes back to the first line. I have no idea what version of Ruby you have right now, and I have a strong belief that friends don't let friends use programming languages from upstream dependency packaging systems. It's not snappy, but it's true. All right, do not install Ruby that way. And then we're going to get the packaging. That's our apps, and then our bespoke, interesting way of running our app. This is just a recipe for never knowing what's actually running in production, or how you might reproduce it with a small change. But nonetheless, if you've gone into the Kubernetes world, you've just assumed this. You probably don't have a better way of living than throwing together a Docker file that most of which you've copied from Stack Overflow. Now, some of you are going, I would never install Ruby that way. Yeah, I know. You've got this 5-line long thing that includes curling it from upstream, unpacking it. Probably got the SHA-256 in it because you're a clever man. Unpacks it, installs it from source, and you're feeling very special with yourself. And while I agree that that is better than this, how are you going to update it? What is the automated system, and whose responsibility it is? How does the organization even know what version of Ruby you've got and whether it needs updating? So it doesn't make you a bad person. It's just this is the scope that I wish you to think about, and why I think Buildpacks. So this is the Etsy website modified for how I feel about Docker Hub. This is what Docker Hub looks like to me in my mind. It's just thousands of home-spun, bespoke Docker things that who knows what's in them. Best of luck. Even if they gave you the recipe, the Docker file, best of luck making the same thing they made. Every Docker image, if Docker files were such a great idea, there'd be one Redis image. Oh no, there are so many that it's not funny. So I say all that because obviously I wouldn't complain about something and just walk off. That'd be rude. Proposal is that we're going to switch to using Buildpacks to generate Docker images or OCIs, and you're going to be happy about that for the rest of your life. So. Now, you might not know, but about a year or so ago, we started talking about Cloud Native Buildpacks, which the history of this is that whilst Cloud Foundry started with Heroku Buildpacks, we did fork them, and Heroku forked their own API. The original API is a very simple set of scripts, and because in Cloud Foundry we started having supply Buildpacks, so we had a couple of different ideas. Cloud Foundry Buildpacks have something that Heroku doesn't care about as much, which is offline Buildpacks. Our Buildpacks can be taken into dark data centers, whether you work for the CIA or some other acronym that's just the same letters in reverse. I don't know, but you have your own reason for not having access to the internet. Then you still need Buildpacks, and they can't just be going pulling resources off the internet. So that's one of the attributes. But when Heroku and Cloud Foundry finally, and I say Cloud Foundry, I really mean Pivotal in this case. People at Pivotal who've been spending, so much money on Buildpacks for the last half a decade. Started catching up with Heroku people. They came to decide, we've got some real challenges and we'd like to have another stab at Buildpacks. And it is a CNCF / Kubernetes incubator project, and it is looking really good. So I wanted to take the opportunity to spend my time sharing about this and how you bring it both to Kubernetes. And by inference, this is the future of Cloud Foundry's Buildpack system. There was a lot of content from both Heroku and or Pivotal that you can go and watch after this talk. But the gist of it is that we are trying to build this thing on the left, which is to say that we're going to have our app, and there's going to be a base run image, probably some form of Ubuntu or Alpine, something tiny or something big, depending on the dependencies. And then these layers that are more specifically provided by an upstream team who cares about that layer. Ruby, Java, .NET Pro dependencies or the Ubuntu dependencies you want to bring in. And then a set of sort of a life cycle of tools that bring these together. One aspect of this is you get free, and that's the ability to rebase. But if you go back to that Docker file where I said from Ubuntu, with a big shrug of the shoulders, one of the things that we got for free in Cloud Foundry, where we sort of had if you've ever thought about what we have in Cloud Foundry, it's a 2-layer image, right? There's the droplet, which is everything the staging did, on top of a base OS, which we call the stack. Put together is your container. And that very simple 2-layer image means that we could rip out the base and upgrade it without your app ever needing to restage. And it's been going on for years. If you've ever deployed an app and never restaged it, doesn't matter. The base OS has always been updated. They just restart your container, your app restarts on top of a base. And so they wanted to keep that ability to rebase all the things you did the last time you staged, the last time you built your image. But the platform team gets to continuously update the base run image. So any CVEs that happen in Ubuntu, assuming your base is Ubuntu, get rolled out without them ever having to find you. For every Docker file, there's a project that needs to be found. And you can't just find the Git repo with the Docker file in it. Like, is it a Jenkins pipeline? Was it deployed manually? Is it a concourse? Like, where is the build? How do you even push this stuff out? So one of the features of Cloud Native Buildpacks is the ability to never know that, but still be able to update the base OS when CVEs get rolled out continuously. So you get that for free. Now, everything else is still kind of in the domain of the developers and their pipeline pushing out the app, but super interesting. So we're going to talk about 2 tools, and whilst there will be more tools, there's more ways to use Cloud Native Buildpacks because it is a set of components, but I am going to specifically talk about the ones. The first one, the Pack CLI, is part of the Cloud Native Buildpack team project. The KPack project sort of kicked off by Pivotal towards them thinking about what it might be, how we bring Cloud Native Buildpacks into CF, plus for their own product suite and for their own Kubernetes users. So we're going to talk about that. But other solutions to use Cloud Native Buildpacks would be the Knative Build or the Tecton project. But if we get the gist of it, then you'll be able to take these ideas with you. So we're going to do live demos with the 18 minutes we have left. But essentially it's this. We're going to take a Node.js app, because they don't take that long to build. We're going to build it. You're going to see automatic detection. The automatic detection you know and love from Cloud Foundry. You're going to see it happen. You're going to see it build a Docker image. Noteworthily built without a Docker file, and noteworthily rebuildable over and over again from cache layers. And we're going to run it. Then we're going to run it as a Kubernetes deployment, not a pod. And that'll be happy times. And then we're going to move on to KPack. So the slides that will go up on the internet have everything I'm about to do. But it would be very, very dull for me just to show you slides of commands written. But it is a backup plan. But no, we're going to leave. All right. This is where it gets exciting. So essentially, the Pack CLI is a CLI that comes with the whole Cloud Native Buildpack toolchain. But it is a local developer tool. It's a bit like running Docker build yourself locally. Whereas the KPack project is perhaps more akin to having a CI pipeline, automatically detect changes in a Git repo, running the same lifecycle that you're about to see, and publishing a Docker image without it ever happening on your laptop. So, and we are going to be running primarily the build command to build our app. Now I have here a Node app, and here I have a Java app, and we're going to go pack build, and I'm going to give it a name. I might as well start to tag it, because I will want to take this and put it in and be able to change my deployment, my Kubernetes deployment. So different tag, or SHA-25, 256. So we build that. By default, it assumes that we're doing it on the current folder, and it is using Docker. So I'm using Docker for Mac, or whatever we call this now, Docker desktop. So the first thing it does is it goes through, and if you've ever done a CF push, if you haven't, you're in the wrong room. If you've ever done a CF push, you will see the automatic detection as it goes through and says, hey, Buildpacks, you figure it out. What's going on here? What is this app? Now, this is, we'll get to the Java one in a second, but this is all one of the parts of the Cloud Native Buildpack project is the idea of breaking them up into smaller components that then come together. So instead of having one massive Java Buildpack, we have lots of little ones. And they figure out for themselves how they come together. So when we go and do pack build on the Java app, you'll see the same sequence. It will find out whether it's a Java build pack first. So this time it was successful in deciding that it was a Java one. It doesn't really say success, it was Java. You can sort of just see that it was this collection of this group. I didn't make that word up. This is the Cloud Native Buildpack terminology. It's a group of buildpacks that, as a group, said, yes, we will tackle this app. For our Node app, it was not that group. It was instead a group that included the Node engine and the Yarn buildpacks that said, we'll tackle this. And there is another group, which is Node and NPM. So depending on which package NPM package managing tool you use, is how they've decided. So, now, it's reused the cache, so it's a bit dull. I will apologize. Now, those colors, are those colors okay at the back? I hesitate to ask because you might say no. Then I would not know what I was going to do about that. They look great on my laptop, and I use them every day. So the idea is here, that, so we're reusing these layers, and we go through, so first the node build pack, basically all it does is brings node. It says, here's node. I don't know what you want to use it for, but this is what this build pack does. It doesn't know how to run a node app. The node engine build pack just puts node on there and then moves on. Where else might you use the node engine build pack? Ruby apps. Ruby on Rails apps like to use it as part of the build sequence for running asset pipelines. Static file apps might like to use it for doing taking the tool chain and building out static apps. It turns out currently the Yarn build pack has responsibility for deciding on how an app will get run, and it delegates to the Yarn start command. And this might change between now and the next time you use it as they restructure these build packs. In the end, it pumps out an image, and then off we go. Down here, where I have not previously succeeded because I can never be bothered waiting for OpenJDK to download, you can see that it's never successfully cached this layer before, so it's now downloading OpenJDK for the first time. Another way they could have done this is had all these internet-based assets put inside big Docker images called the builder. And when we do the next talk tomorrow, we talk about building these build packs. We might talk more about these sequence of events. But you can sort of see that first we do detection, which group of build packs will be applied. And your organization might be different from your organization on what group of build packs are going to be applied. Maybe you include some APM build packs so that every app has some process monitoring in it, and maybe yours doesn't. And so you can evolve over different collections. A bit like in Cloud Foundry, the platform team can do CF create build pack and curate that list of build packs. This is going to allow us to have more granular access to how we curate build packs. All right. So here it said we had an image. Docker inspect that image. I don't want to see this anymore. You can go away. Now, you don't need to care too much to say. Suffice to say that because it was built with the pack tool, even though it is a Docker image, just like you could have built this Docker file, we get a lot of metadata. That it means that a platform team can now look at all the images and inspect what's in there and learn things. All right, now we can run it. Docker run -t -p. It's going to listen on. And there it's running, so curl. All right, that is the internet running on my laptop. And so much nicer. I mean, again, just because I talked, you might have missed it, because I made it take longer than it should have. But instead of writing my own bespoke Docker file built from 17 different Stack Overflow pages and three or four other projects from before, never quite the same, always slightly better than the last one. Which is just a terrible way of saying that every other Docker file is wrong now. We now have one way to build Docker images, which is pack build, or the lifecycle tool in the build packs. All right, so now let's do the Kubernetes part of this. So there is just the example with some color of some of based on the app that was uploaded, some of the Java build packs were used and others were not. So you can sort of see that Tomcat was selected. Spring Boot was selected, JDBC was not used. Now, in order to do the Kubernetes, my Kubernetes is running in the internet, so it's not on my laptop, so I do need to publish that image. I could either push like that, or our pack build command does have a publish flag. I have already published one, so we will move on and look at our deployment. It's a very simple deployment. It's made up of a pod and a service so that we can access the thing. And here is our image. So the V001, it's got some replicas. It's just some good old-fashioned Kubernetes, lots of YAML, but not so much that you'd think it's bosh, but just enough that you don't know what it says. It's in that happy place of why we get paid so much. And so the real part is this part. As long as it runs, and then the service will route traffic from port 80 to port 8080 on the pod, and life is good. All we need to do is kubectl apply. So close. Deployments. Get pods. We'll watch them come up. There's no reason for them to still be there. That was terrible. Look. That wasn't very good. You know when you prepare for a talk and you go through it one more time before you go up and you think to yourself, the last thing I need to do before I go on stage is to delete everything I just did? I didn't delete everything I just did. So let's start that again. Apply deployment. So as we said in our YAML file, we're going to have a deployment and a service. All right, they're running because the image, that's right, because I didn't build a new image, it didn't take very long for it to download the image. But normally it would say creating a container, and you're wondering what the hell is going on, and what it's doing is sucking down a huge Docker image, but it gives you no progress information whatsoever. And there's a ticket on that, and they won't do anything about it, and I find that quite tedious. Nonetheless, that's why it was really quick. Get service. So now this is where we're just waiting for, in my case, it's Google Cloud, waiting for it to give me a load balancer. You're here for a Kubernetes talk. This is some Kubernetes. Love it up. Sure, if it's CF push, it'd be done by now. We could all go home, but this is Kubernetes. This is what you came to see. I don't want to judge you. I'll just use a mocking tone. Come on, Google. To be fair, I am still referring to my cluster that's based in Australia. But that doesn't change anything. Give me a load balancer. Stupid. All right. While we wait for that load balancer, let's move on to the next thing. We will curl it, and it will come out, say hello world, and you'll all feel special. So next thing we're going to do is change it in preparation so that you can see that it builds a second time. What will we do? We'll do pack. Oh, I've got to change the app to do something different. So we'll say hello CF Summit. Yes, that's very bespoke and interesting. And we'll give it a thing, and we'll do publish. I'm getting suspicious that something's wrong. I mean, if it works, that'd be great. And if it doesn't work, that's less good. There we go. All right. So we have our. So we're still the deployment is still just the V1. I should say, hello world. Excellent. Look at us. So now we've built and we published version 2 or 002. So let's do a bit of a watch command. All right. So it's now just hitting that service over and over again, asking for it to go to one of the pods. But now we have shipped version 2. Let us go to the deployment and deploy version 2. And then do a watch, do a get pods. All right, so it's shutting down, it's running the new ones. There we go, hello CF Summit. So, the internet works, lovely. And by the way, that's all coming from Australia because it's just a great place to put code. I don't know what the status of Brexit is, so I'm just going to use a different continent entirely. Guaranteed to be Australian because we're all, monolingual over there. All right. And again, at no point did we Dockerfile. We just took our Node app and said, hey, you run it. What do I care? And we could do that for the next 10 years. Someone else is curating those. It's a nice separation of concerns. Some other organization, in this case, an entirely different company in the planet is looking after those build packs. Or another part of your organization can be looking after the build packs. Someone else can be looking after the base OS. Someone else can be looking after the Node build packs, the Java build packs, Ruby build packs, and your dev teams, as they come and go, can just worry about the code aspect. I mentioned that there is both a Yarn build pack and an NPM build pack. Sure, could have been put together into one build pack, but it's a nice example of separating just into different functional components of how you want to do the running. All right, KPack. We have 4 minutes. I tell you that just so that you know that I care about time, which I generally don't. So it's just we're all trying something new. KPack is, so previously I ran Pack, it was on my laptop. Now there is a concourse resource that wraps up Pack, but it's kind of ugly in the sense that you've got, you're already inside a container, and then you're running KPack, you're running the Pack command, which needs to talk to Docker. So you run another Docker daemon inside your container and generate more containers inside containers with escalated privileges. It's a little bit ugly, but it works, albeit it doesn't get caching. KPack is an attempt to have a running service that sits there automatically building images. Whether you choose to use them or not is left to your CI pipeline or your process. So it's just going to publish the images. It's then up to you to figure out whether you want to, what app they're going to be deployed out to. Staging, possibly production. Okay, and it runs in Kubernetes, so that's obviously a good thing for a talk on Kubernetes. It does, so later on when we start to bring KPack to CF, it suggests that it will come in alignment with, either they'll do it without Kubernetes. It is just bits and pieces. I don't think it's necessarily a Kubernetes thing. It's just they took the lifecycle components, detect, build, image, caching, and package them up as a Kubernetes controller. So either they might assume that by the time they bring it to Cloud Foundry, we've got Arini and it's assumed that no one's using BOSH and you've always got Kubernetes, or they might have to unpack it from Kubernetes and run it as a BOSH thing. It's in the future. But we're going to do this now, and it's going to be awesome. So, first things first, what is KPack look like? We could do API resources. So I've already installed it on my cluster. It's just a release file that you install, and it gives you about 5 or 6. There's 4 of them, resources. And the key ones maybe are images. That's basically saying there is a source, and I want to build an image. Anytime the source changes, build me another image. Every time that happens, it creates a new build. And that's just a record of all the times it's attempted to build something. And we can watch the logs, and it's lovely. So that's what we're going to do. Now, for your convenience and mine, I've already built a resource or a YAML file that's going to do this for it. So this is the GitHub repo that this project is at. I will, for your benefit, make a commit and change it and watch it rebuild, but we'll start with whatever's on there. We're going to move on from using version tags to just using the shars. And another thing of note perhaps is the caching. So I've got caching on there. Look at us, we've got the same thing. I was not looking at your signs at all. Completely not, I don't care anymore. I'd rather just do the demo. So you get the benefit of caching. So it is, so now we can do kube, get builds and images. So the YAML said that it wanted an image, so we created an image. So the image came from the YAML, but the build came from the first time it went and fetched whatever's on the Git repo. The KPack project comes at the moment with a CLI called logs, which is how you get to watch the build process, either live or historically. Due to lack of time, just whatever's about to come out is the same as what it comes from Pack Build, with less color. Don't know if there's a way to get color. I do like the color. If I could have the color back, that'd be great. And then I will we'll let that finish. Where am I going to do this? I can get that later. What have we got here? So now that we've changed, so locally we changed it to say Hello CF Summit. Now I'm going to commit that. So the first image is going to be based on the Hello World contents. I'm going to commit this Hello CF. And what we should see is that we had one build, and it will resolve. So it keeps saying that it's the first build because it keeps updating with the new logs. And eventually it will find the new commit, and we'll get a second build. I'm not sure what I want to watch. It's all very exciting. So many things to watch. No, didn't mean to. I've done a terrible. That was the wrong thing. That was the worst command ever. I just killed the whole window like an idiot. I want my curl command. No, it was watch. That one. Yeah, look at that. Oh, that's because it's the other one. All right. Just forget it. We will finish up. So kpack is basically doing the same thing as the pack command. It's taking that life cycle, pulling down commits and rebuilding. You would then watch, you'd go kube, get images, and you can see the first build is finished, and we can take that full URI and give that to our deployment. And do kube, apply, because I'm in the wrong folder. Pretty desperate just to finish this. And that would deploy out. So essentially, kpack will keep building images. It's then your responsibility, because you love Kubernetes, so you don't want anything to be done for you, to then take that SHA, put it in your next deployment, and push it out wherever it needs to go. Okay? So that's the future of that's the bits and pieces we have in the future. So we've got a full ecosystem of Buildpacks, pivotal, doing a huge amount of work in this. Obviously, you might want to build your own Buildpacks, and then this tool chain. And really, I'd hope 80 to 90% of your apps can now be used with Buildpacks rather than bespoke Docker files. So thank you very much.